Hello everyone, welcome to another lecture on C++ programming language. We are on lecture 12. So in lecture 12, we will talk about bitwise operators. So we are in lecture 12 and we will talk about bitwise operators. So bitwise operators are operators which operates on bits. So these operators are specifically used to perform operations on bits. As we studied on lecture 1, computer or CPU only understands 0 and 1, which is called binary language. And these operators perform operations on binaries, on 0 and 1s. So let's see. As we see here, bitwise means it performs operations on bits. So in this category of operators, we have the first one, we have bitwise AND. We have bitwise AND, which is represented by the symbol of ampersand, or we can say AND. I can write like this. So bitwise AND operators, operator is used, to perform operation on bits, and it returns only 1 if both operands are true or 1. So for example, if we have a binary number, like we have 0, 0, 1, and another binary number like 1, 1, 0, 0, and we want to do it an AND operator. So the AND operator, or the AND, bitwise AND, only returns true if both values are 1. So now if we do 1 and 0 become 0, the result. Why? Because the first operand is 1, but the second operand is 0. Then we have 0 and 1. So then again the result becomes 0. Why? Because one of the operands is 1 and another is 0. The third one, if we come here, 1 and 1 become 1, because both operands are 1. And the last one becomes 0 because none of them is 1. So here we performed AND operation, and it is used also in networking on subnet, defined subnet and subnet mask on a network. So here we can see the AND operator only returns 1 if both operands are 1. Then we have another operator, bitwise OR. We have bitwise OR, and this is the symbol. The bitwise OR is used, to perform operation on bits, but it only returns 1 if one of the operands is 1. If one of the operands is 1, so it returns 1. So let's check this example, like the same example we use. We use here OR. So the OR operator returns 1 if one of the operands is 1. So here 1 or 0, it becomes 1. Why? Because one of them is 1, one of the operands. So the first operand is 1 and the second is 0. So the result is 1, because at least one of the operand is 1. Then the second, 0 or 1, it's become again 1. Why it's become 1? Because the second operand is 1. Then 1, 1 or 1, so it's become 1. And then the 0 or 0 become 0. So the OR bitwise operator is used. It only returns 1 if one of them, at least one of the operands, is 1. So this is called OR operators. Now we have another operators. We have bitwise AND, bitwise OR. Then we have bitwise XOR, which represent by the symbol of this. The XOR or exclusive OR operator returns 1 if both operands are different. If they are the same, it will return 0. If both operands are different, like one of first operand is 1, another operand is 0, so the result will be 1. So let's check it. If we change our example to the, this example to the use XOR. So I use the XOR and we perform, XOR operation on this, or exclusive OR. So 1 XOR 0 become 1. Why become 1? Because both of them is different. This is 1, this is 0. Then 0 XOR 1 become 1. Because they are different. And now 1 XOR 1 becomes 0. Why? Because they are the same. And then 0 XOR 0 become 0. Why? Because they are the same. So Bitwise exclusive OR operator returns only true if both operands are different. If they are the same, the result will be 0. Then we have another, bitwise operator, which is called NOT operator. Bitwise NOT. And it's represented by this symbol. Bitwise NOT is used to perform operation on bits, but it's need only one operand. So if we have, like, for example, if I say here, like if we have a number 0, 1, 0, 1, 0, 1. So this is a number. And if we want to use Bitwise NOT operator, so if we use this one and we use the Bitwise NOT, the result will be the 1 will be changed to the 0, the 0 will be changed to the 1, and the 1 will be changed to the 0, and 0 will be changed to the 1. So it means it changed the 0 to 1 and 1 to 0. So it is called Bitwise NOT. When we use the Bitwise NOT, it changed the 1 to the 0 and 0 to the 1. So this is called Bitwise NOT. Then we have another Bitwise operator, which is called Bitwise left shift operator. So let me write here. Bitwise left shift operator. Left shift operator. The symbol is like this. It means it changed the location of bits from, when we use this operator, so it changed the position of, bits in. For example, if you use this operator here, like if I define an integer value, like integer is equal to, for example, 0, 1. So I use here binary. 0b means binary in C++. So I put a 0b here and I say here 0, 1. For example, I put here 1, 0, 1, 0. And I store this one inside C++, inside a variable called a. So when we store a binary number in C++, we use the 0b in front of, or the number. So this is a binary number. And if you want to use, the left shift operator, so I see integer result is equal. So I say shift the value of a by 1 bit. So here, if I write 1, it shifts 1 bit. For example, it shifts to the left side. If we can see here, now this number, if I change this number to the decimal, it's become 1, 2, 4, 8. So it's become 2 plus 8 become 10. This number in decimal is 10. If we change this number to decimal, it's become 10. If we shift this number from left to if we use the left shift operator, so it shifts the position to 1. So we use one location. We want to change one location. So here what happens, this bit is going to one location this side. So it's become what? It's become 1, then we have the 0, then we have 1, then we have 0, then become 0. So the value will be now, if I change this, it's become 20 in decimal. So it shift the value of the operands by 1 bit to the left side. So this is called, bitwise shift operator, bitwise left shift. And don't worry about this if you don't understand this, because later we will come if we need it. If we need it in our program, so we'll come back. And then we have bitwise right shift operator. So it is, the symbol is this side. The symbol is this side instead of this side, right side. And it's changed the position to the, to the right side. Whenever we define first position, second position, if I would want to use, the right shift, here I can say change the position of the A value 2 bits. So it shifts 2 bits, like it shifts 2 bits. So when we use the right shift operator, it shifts or it changes the position of bits to the right. We define how many positions should be changed. Like we defined, like for the left shift, how many positions should be, change the value of our variable, the value of the bits from the position to the left side, like 2 bits or 3 bits or 4 position or 5 position. So we can use these, left shift or right shift operators. So these were all about, bitwise operators in C++. So we have, let me repeat again or summarize the lesson. So bitwise operators are operators which perform operations on bits. We have bitwise AND. The bitwise AND operator only returns 1 if both operands are true or 1. Then we have bitwise OR operator. It only returns true which at least one of those operands should be 1. Then we have bitwise XOR, which returns true if both operands are different. Then we have bitwise NOT operator, which change the value of 0 to 1 and 1 to 0. And then we have bitwise left shift operator, which shift the position of a bit to the left side. And when we have bitwise right shift operator, which shift the position of a bit to the right side. Hello everyone, I'm back in my system, so let's open our IDE. So now we have a project here. So we are in lecture 12 and we discussed about bitwise operators. So bitwise operators in C++ are used to operate on bits. When we need to, perform operation on bits, so we need to use these operators. But in this video, I'm going to talk about and give you example of these 3 bitwise operators. First, we discuss about bitwise AND, which the symbol is like this. It's ampersand. So the bitwise AND returns true if both bits, are 1. Like it's like logical operator AND. If both of the conditions were true, so it returns true. Otherwise, it returns false. The same, is with bitwise AND. If both bits are 1, so the return will be 1. Otherwise, the return will be false. So let's give an example here. So if we have integer a is equal to like I can say 5. And if I have integer b is equal to like 3. So now if I see out like I integer result is equal to a and b. So now I see out, so I say a and b is, so I print the result. So let's run the program and we see the result. The result of a and b is 1. Why? Because if we change the a, which is 5 in binary, if we change to 5 in binary, it is like, let me change in binary. So it will be, so if I put 0, 0, 0, so I on the first bit, and this is, if we convert the 5 from decimal to binary, this is the binary form of, 5. And if we convert the 3 in the binary, so it will be 0, 0, 1, 1. And now if we perform AND operation here, so 1, 1 and 1 become 1. And then because both operands, both bits are 1, so the result will be 1. 0 and 1 will be 0. 1 and 0 become 0. And 0 and 0 become 0. So if we change this number from binary in decimal, it will be 1. So the result is 1. So now let's discuss about the second operator here, which we have in Bitwise. It is, Bitwise OR. Bitwise OR, which is, we have a vertical line here, the symbol. So Bitwise OR returns true if at least one of the bits is 1. So let's check it. In this case, if I change this one to the OR, the AND operator to the OR, let's print it out and let's check the result. So I run the program and I see it shows the result is 7. Why? Let's do it OR operator now. So I remove this one. Now we are doing OR. So 1 or 1 become 1. Okay. So now 0 or 1 become 1 because one of the operands at least should be 1. 1 or 0 become 1. And 0 or 0 become 0. So if we change this number to the decimal, it's become 7. So now if you can see, the result is 7. So don't worry if you don't understand now, changing from binary to decimal or from decimal to binary. I will create a course for that one. So I will teach you, what is binary, what is the binary system, what is the decimal system, what is the hexadecimal system, how we can change, the number between them. So for now, just understand that the OR operator is used when it returns 1 if at least one of the bits is 1. So now let's discuss about the third operator which we have in Bitwise. It is Bitwise. We have Bitwise AND, then we have Bitwise OR, and then we have Bitwise XOR, which the symbol is this one. So the XOR is returned 1 if, both bits are different. If it is 1, 1, it returns 0. If it's 0, 0, it returns 0. But if one bit is 1, another bit is 0, it will return 1. If one bit is 0, another bit is 1, it returns 1. So let's check. If I now change this operator from OR to the, to the XOR, and now if I print out the program, so let's see the result. If I compile and run, it shows it's become 6. So let's check and perform the XOR operation on these two numbers, the number 5 and the number, 2. 3. So let's perform XOR. XOR 1 XOR 1 becomes 0. Why? Because both the bits are the same. So the result is 0. Then XOR is 0. 0 XOR 1 become 1 because they are different. So the return will be 1. Now XOR 1 with 0, 1 XOR 0 become 1. Why? Because one bit is 1, another bit is 0. So both of them are different. So the result will be 1. And 0 XOR 0, because they are the same, it's become 0. So now if I convert this number into decimal, so it will be 6. So the result we see here, it is 6. So also you remember we can store in C++, if we want to store binary number in C++, we can do that. We can, like if we can define integer x is equal to, like if I now store this number inside the x, we can do that, but you should put a 0b at the beginning, then you put your binary number. So we have 0, 1, 1, 0. If I print the value of x, now it should print for me 6. So let's, write down here, like I want to see out x is equal to x. So let's, compile and run the program. You can see x is equal to 6. And we already talked that this is the binary number for the 5. If we change the 5 from decimal number to the binary, it becomes this. So let's store this number. We are right or wrong? So it is 0, 1, 0, 1. Yes? 0, 1, 0, 1. So now let's run our program and we can see x is equal to 5. The same way, if we put 0, 0, 1, 1, it will be 3. So you can store 0, 0, 1. So you can store, the binary numbers into inside a variable in C++, but you have to use as 0b as a prefix for that number. It means it's a binary number. The 0b tells the compiler that this number is a binary number and you want to store inside integer x. If I run this, it will be 3. The value of x is 3. So I'm not discussing about other operators like NOT operator, Bitwise NOT, Bitwise left shift or right shift to make it the program much complex. This lesson I'm not going to discuss that, but I will, after finishing the C++ lecture, I will create another lecture because you are now started programming, and I am not going to make it complex because right now we don't need them actually to discuss here because they are much more complex. So I will create more lectures, a series of lectures for binary numbers and then decimal, then hexadecimal, how we can change them, and then we discuss about this on those lectures. So for now, it's enough to you understand these 3 bitwise operators in C++. So this was today's lecture, and thank you for watching and see you on the next lecture.